conduction, convection and radiation. So conduction means heat transfer one place to another. Convection means the heat molecule transfer one place to another. Okay, see the slide for conduction and convection and radiation. So the specific capacity of the solid and liquid. The definition of specific capacity of the solid and liquid. In other words, the specific capacity of solid or liquid in the amount of heat that rises the temperature of unit mass of the solid through 1 degree Celsius. The symbol is C. The SI unit amount of heat that rises the temperature of 1 kg of solid or liquid through 1 Kelvin. So the specific capacity, the formula, the specific capacity of the substance is the amount of energy required to rise the temperature of 1 kg of substance by 1 degree Celsius. Therefore, the symbol of C, the specific capacity of the liquid, C equal to del E divided by M into del into theta. Therefore, del E equal to minus M into C into del into theta. So, M means mass in terms of kilogram. C is the specific capacity. The joules per kilogram degree Celsius. Del E, change in the thermal energy, therefore J. Del theta, the change in the temperature from initial temperature to final temperature in terms of degree Celsius. The slide show and the diagram show that the temperature and specific heat, the maintaining in the material, the observing the temperature of the material is a formation of the material depend on the temperature. At the level of the 1 gram of the material and the degree Celsius one side, he apply to the one quantity of chlorine or mole. What about the material? So water is maintaining in the minimum degree Celsius. Normal of the place of the water maintaining in the minimum degree of the Celsius. For example, 1 degree Celsius. Gas line, second one gas line maintaining in the 2 degrees Celsius. At the gas line is at level of temperature maintaining the gas line. Suppose we apply to the temperature or reduce to the temperature, will be changing the material one place to another. Okay, at the rubber and plastic, the upset seed, the aspen, cement, spherical and steel, copper. The highest of the material will composite of the highest temperature at the goal. Okay. Next, the Dulong and Petitla. So Dulong Petitla means the maintaining in the or formation of the highest temperature in the material. So will be find out the Dulong and Petitla. The Dulong Petitla said that the product of specific heat and amount atomic masses or gram atomic heat capacity of an element is always a constant. The specific heat and atomic mass, specific heat and atomic mass or gram atomic heat capacity of an element is always a constant. It is a constant for all solid elements. It is not applicable for liquid, only for a solid. Solid and it will be forming in the highly temperature material. We can on the atomic mass, the highest atomic mass and specific capacity, highest specific capacity and gram at the heat capacity of the element, always constant material. Okay, the Dulong Petitla and the equation. The Dulong Petitla calculate the atomic mass and valence of elements. The formula C, the small c m equal to k, where c equal to the specific heat capacity, m is the molar mass, k is a constant. The graph show that the applicable for high temperature of Dulong and Petitla. So the maximum the formation of the material for lead temperature 400 degrees Celsius. Second one aluminum, third one silicon and fourth one diamond. It's a constant temperature. It means always the element also constant. That is called the Dulong and Petitla. Take about the value y-axis in the constant volume. X-axis is a temperature in terms of Kelvin. If put about the value of the T value and a constant volume will be formation of the graph. The minimum formation of the lead and aluminum and silicon and diamond. It also is a constant element of the constant elements in the formation of the material. Okay. In the above diagram, the curve of the silicon is flattening out of after 600 Kelvin. After 600 Kelvin and lead curve flattening at 200 Kelvin. The graph clearly shows that the law of applicable at the various higher temperature for different element. Various higher temperature for different element between the laws using the Dulong and Petitla. Is it clear? Next. The limitation of Dulong Petitla. So, you know the only applicable for solid material, but a different or a variable temperature using the or a constant temperature using the Dulong Petitla. But a limitation of Dulong and Petitla. Dulong and Petitla is the only relevant to the heavier element. Only relevant heavier element. Once you know the formation of the highly temperature material. Okay. It is only applicable to element that in a solid form. Okay. Only material in a only applicable to the element that are in solid form. That is a drawback. Okay. He is mentioning you using the liquid form or gas form. That is not using the applicable for Dulong Petitla. Third one. It cannot be applied to lighter element having high melting point. Okay. Lighter element, but because the gasoline and the cement also light material applicable for high melting point. So fourth one, last one, it's only gives a raw atomic mass. Raw atomic masses means an highest the forming melting of the temperature material. So okay, clear? So second, next one, the Newton law of cooling. Okay, the Newton, you know the Newton, and the specific capacity, the gravitation produce the Newton. So the Newton law of cooling. See about the Newton definition. According to Newton law of cooling, the rate of loss of heat from a body is directly proportional to the difference in the temperature of the body and its surrounding. Is it clear? Once again, according to the Newton law of cooling, the rate of loss of heat from a body, rate of loss of heat from a body is directly proportional to the difference in the temperature of the body and its surrounding. Okay. Suppose take up the vessel inside of the liquid heating. First heating. Say maximum boiling temperature water will be rising and the boiling temperature 100 degrees Celsius. Okay. Say maximum heated in the water. He placed in the environmental position. Okay. He react with the atmospheric temperature. So reduce to the temperature in the heated of the water. Okay. He come to the heating is directly proportional to the loss of the heating and is in a surrounding. So it depends on the surrounding. So in heating the normal to the normal water. Okay. You take about the one experiment for Newton law of cooling. Take about the experiment. For example, see about the cup of teas. Cup of teas before the temperature of the 30 degrees Celsius. Normal heating the tea is a normal heating the tea is a maximum temperature 30 degrees Celsius. After some time the temperature will be reduced. A place in the tea will be surrounding or environmental position. So the temperature will be reduced. It's a loss of cooling. Okay, loss of cooling. So experimental method, the standing with a bowl inside of the liquid will be heating the process. Okay, some how will heating the process inside of the thermometer will be increasing the temperature ranges from 0 degrees Celsius to 100 degrees Celsius. Okay, so Newton law of cooling is given by dt divided by dt, that d capital D divided by d into small d equal to k of T1 minus Tt minus Ts, Tt minus Ts, where Tt is a temperature of the body at a time t. Okay, the temperature of the body at a time t. Ts is a temperature of the surrounding. The K is a positive constant dependence on the area and the nature of the surface of the body.